One of the most important and most powerful problem-solving techniques involves analyzing a problem in terms of the units given in the problem. This is what is known as dimensional analysis. Now, dimensional analysis is something you probably already do. For example, when you go to the store and you decide to buy X over Y based on value, that is dimensional analysis. Now, what we're going to do is we're going to use it in terms of problem solving to determine how to attack a problem and how to achieve the desired outcome. So the first thing in a dimensional analysis problem is to determine what units you have. What are your given units? Then you need to figure out what unit are you looking for, your desired unit. And in order to get from your given unit to your desired unit, you need to look at what are the possible ways or what tracks can we use to get to that desired unit. These are called conversion factors. And we're going to carry the units throughout the calculation. And if we do it right, we're going to multiply our given quantity by our conversion factor to get our desired quantity. Note, the given unit has to be on opposite sides of the multiplication of the desired over the given. Now let's take a look at how we present our conversion factors. One very common conversion factor is 1 inch equals 2.54 centimeters. This is written as an equality. It states that this 1 inch is exactly equal to the 2.54 centimeters. Now this is the case where this is an exact definition. Now what this means is that this is an infinite amount of sig figs. This equality can be written in two different ways. If I divide both sides by 1 inch, I get 1 inch over 1 inch equals 2.54 centimeters over 1 inch. Now 1 inch over 1 inch is 1. Or I could divide both sides by 2.54 centimeters, in which case I get 1 inch over 2.54 centimeters equals 2.54 centimeters over 2.54 centimeters, which again is equal to 1. Now which form of the conversion factor we use, 1 inch over 2.54 centimeters or the 2.54 centimeters over 1 inch, really depends upon what unit are we trying to cancel. So if we're trying to cancel centimeters, that should be the conversion factor we use, where the centimeters is on the bottom. But if we're trying to convert inches to something, then inches needs to be canceled. So we would use the second form. So let's do a simple problem. How many centimeters is 25 inches? So we're going to take what we know, 25 inches, and we're going to multiply by a conversion factor. Now, what needs to cancel? The inches need to cancel. So we're going to multiply by the 2.54 centimeters over 1 inch. So inches cancel, and we're left with 25 times 2.54, which equals 63.5 centimeters. Now, look at the number of significant figures we have. In our original question, we had 2 significant figures, so my answer should only have 2 significant figures. So 63.5 becomes 64 centimeters. Now let's take what we've learned and apply it to a slightly more complex problem. Example problem 1.6 states that the average daily intake of glucose is 0.0833 pounds, and we want to know what is this mass in milligrams. And they're good enough to tell us how many grams are in 1 pound. So I started off the problem by listing what I know. I know that the mass of the glucose is 0.0833 pounds, and I know the conversion factor from pounds to grams. What I don't know is how many milligrams this is. Now I need to plan my conversion. I know that I've got to get from pounds to grams. I have to get into the metric system. So I'm going to use my conversion factor. Now, which form of the conversion factor am I going to use? I'm given pounds, and I need to cancel that out. So pounds needs to be on the bottom, so I'm going to choose the second form of the conversion factor. So if we write this out, we take the 0.0833 pounds times this conversion factor of 453.6 grams over 1 pound. But grams isn't my final unit, my desired unit. Milligrams is. So what's nice about this is I can actually wrap my conversion to milligrams into this conversion factor setup, this dimensional analysis setup. We know that 1 gram is 1,000 milligrams. That's because milli is 1/1000th of a gram. So I can actually multiply by a conversion factor. Now, if I want to cancel grams out and put milligrams on top, I know that 1 gram is equal to 1,000 milligrams. Now, grams cancel, pounds cancel, I'm left with my unit of milligrams. When I do this, I get the answer 3.78 times 10 to the 4th milligrams, using 3 significant figures in my answer because I had 3 significant figures in the beginning of the problem. Note, the 1,000 milligrams and 1 gram do not contribute to the significant figures because this is a definition, and defined numbers have infinite significant figures. Moving on to a slightly more difficult problem is example 1.7. An average adult has 5.2 liters of blood. What is the volume of blood in cubic meters, meters cubed? So stating what I know, 5.2 liters is the volume. I want to find cubic meters. That is my unknown. Now, I do know that the definition of the liter is 1 decimeter by 1 decimeter by 1 decimeter is 1 liter, or 1 cubic decimeter is equal to 1 liter. See, knowing the definition, I've created my own conversion factor from liters to cubic decimeters. So I want to cancel out liters, so I'm going to take what I know, 5.2 liters, and liters needs to go on the bottom to cancel out. So 1 liter is 1 cubic decimeter. To get from the cubic decimeters to cubic meters, I don't have a straight conversion, but what I do know is I do know that 1 decimeter is equal to 0.1 meters, or 1/10 of a meter. Since I know this conversion, I can put decimeters on the bottom, so 1 decimeter is equal to 1/10 of a meter, or 0.1 meters. But that's linear. I'm looking for cubic meters and cubic decimeters. So what I can do is I can actually go through and cube every number. And when I cube every number, I now have cubic decimeters and cubic meters. But I have to make sure that I cube every number as well, because this is linear becoming three-dimensional. The answer I obtain is 5.2 times 10 to the minus 3 cubic meters, which makes sense because all I've done is multiply by powers of 10. So here have been a couple examples of how to use dimensional analysis. The first thing in dimensional analysis you always want to do is, number 1, know what units you're given, the given unit. Number 2, know what unit is wanted, the desired unit. And number 3, know your conversion factors. When it comes to conversion factors, the second page of your text has a list of all the useful conversion factors you should know. I specifically would know pounds to grams, inches to centimeters, and gallons to liters. This will give you a good start on being able to do dimensional analysis. There are many, 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 many other conversion factors, but you may look them up as needed.